You don't need.
I need my USB-C.
What do you need a charger, man? It happens. Here you go. What's that? It happens.
Should probably go sit somewhere else.
Okay. This is unimpressive showing. So let's see. Tony Strauss. Gordon. Gordon was here. Not Gordon. Sorry, Logan. So I was reading Gordon, then Logan. I knew you were here. Logan was here. He disappeared. Okay. So I thought I'd start with two things just to show you. This one I think is pretty cool. It's Amazon. It is a future engineer scholarship. It does require need, but you can get a scholarship to up to $40,000 if you are thinking about majoring in computer science. There's a whole bunch of stipulations. But I thought it was kind of a cool thing just to see, you've got eligibility requirements. The link to this, if you have any interest at all, is on the homepage at the bottom down here. It's Google Scholarship. So that's one thing. I'm going to drop that over there for other classes. The next thing is this, which I have as a paper hanging on the wall over there. And I thought this was really interesting. So obviously a whole bunch of Stanford researchers went in and tried to look at whether or not majoring in computer science can improve general problem solving skills. So this is not like problem solving in computer science. And what they did, if you read the abstract, I was tempted to make you all read this paper, and maybe I will. But they went through and had a whole bunch of different majors, both humanities majors as well as STEM majors and like computer science majors, do some problem solving, both sort of early stage, so like freshmen and then seniors, ostensibly. And the interesting parts of this are this. So average solution scores by major, the highest I think you could get was a 6. And year. So we have non-quant, quant, and then CS. So what do you notice? What's that? For what? For CS upperclassmen, okay. What else do you notice? There's a pretty big gap between, yeah. So like sub 2 versus almost 3 here. That's a big gap just between non-quant and quant. Are we clear on quant and non-quant?
Like quantitative analysis?
No, just quantitative in terms of numerically based, right? So you could go in and look at the actual piece, right? So I'm assuming they're talking about, if they're talking about quant, so let's go look at what they're talking about. See if we can find how they define quant. Three category majors: quantitative natural science and engineering, computer science, and all others. So quantitative natural sciences, what do we think they're talking about there? Here we go. There's your listing. Chemical engineering, chemistry, civil engineering, electrical engineering, math, mechanical engineering, product design. So they're putting like biology on the non-quant side, economics on the non-quant side. So that's how they're splitting it out. Right. And in designing a study, that's one of the decisions you have to make, is how do you break out things like that? What else do you notice about that chart? So
just the error bars are bigger for non-quant.
yeah, they're a little bit, yeah.
A little bit for non-quant.
Yeah. Right. Yeah, it's pretty interesting that, so what does that tell you? Like, and this is unfortunate, but a lot of studies have actually looked at this. What does this tell you? what does it suggest? They're not learning problem solving. Like whatever they're learning, it isn't problem solving in college. What does this tell you? Students, see how students are learning, because if this were the same, what could we potentially argue that what could we argue if, say, this bar were roughly the same as upper was the same as CS1?
They're not learning problem solving.
They're not learning problem solving, but what could we say? Well, like, could we say that CS students learn problem solving better? Maybe they're just better problem solvers, and that's why they go to computer science, right? Because computer science offers a lot of problem solving opportunity. But this suggests that computer science students actually are learning problem solving where a lot of other students aren't. And I thought that was really, really interesting. And it's one of the things that I love about computer science. Why do you think that might be? Yeah, Danny?
Because when we have to like write a program, we don't like, it's not really like other stuff, this kind of memorization, like in chemistry, you memorize a formula, we can't really like memorize a program, we have to like figure it out. And we have to like kind of fail sometimes, so it helps us like after we do one problem, we can see another one that's similar, or we're better at it, at least in my opinion.
Yeah. And are there ways that you attack problems that would transfer over potentially to other problem solving skills?
Yeah.
Yeah, like computational thinking, like those 4 pieces of computational thinking, you can apply to anything. And so I just thought this was really interesting. And it makes me feel good about what I'm doing. So, but an interesting piece. Okay, so that's that. And then we're going to dive into a few pieces here. Okay. We're going to back up like a half step just to be on the same page. So we're going to do a little bit of lecture here just to make sure that we're sort of all on the same page about static and dynamic type, because there's a couple of things that are going to become really important as we move forward that I want to make sure that we're well grounded in. First, we'll update Alex so he's no longer absent. And then I'm actually going to let you watch this guy talk. So this is from 61B, and it goes along with some of the stuff we were talking about in terms of inheritance, and then doing the
all those things that you learn overly complex set of rules how things work. But there's actually a simple way of thinking. So the way to think about this is that every variable in Java, when you declare one, has a compile time type.
Why is that frozen?
Static type, and that thing never ever changes. So for example, when I say living thing LT1, I get a box. And this is a memory box at 64 bits, and it can only ever point at the living thing. Now, every variable also has a dynamic type, sometimes called a runtime type. And this is the type specified at instantiation. That is when you say do. And it's equal to the type of the object being pointed at. That's what we mean by runtime type. So at this point, I haven't instantiated anything. So the dynamic type, we'll just note as null. Along comes this next line of code. We make a new box, and we say LT1 equals that. So a new box gets created, we copy its address into LT1, here's that creature, and now we have a dynamic type in this box. It's the type of the object being pointed at. So we'll continue. So next comes animal A1 equals LT1. In this case, we get a new box that holds animal references. Its static type is animal, and it never changes. In fact, look, it's like inscribed right on the box. Can't get rid of that. And its dynamic type is box. And we can also have variables of static type box. That's fine. But I make a variable with static type box. It also points to box. And in this case, the static and the dynamic types are both box. Lastly, we decide LT1 is now going to point at a new object, which is squid. So the static type, of course, does not change because it never does. But the dynamic type is now squid. Okay, great. So what? Well, this is the rule thing. If you know the dynamic type of something, then you know what happens with an overridden method. So suppose we call a method of an object using a variable which has compile time type X and runtime type Y. So for example, compile time type list and runtime type slist, as shown here. Then if it is the case that the dynamic type overrides the method, then the dynamic type method will be used instead. And that's something known as dynamic method selection. This term is a little bit obscure. It's not totally standard, but I don't really have a great term, so we'll use it in our course. So in this case, whenever we call something, even though we're using the variable S1, which is this variable right here, because of the fact that the SList class overrides it, we use the dynamic types method instead. That's what you need to know.
Does that make sense? We're good with that? Okay, this is going to get confusing and that's why we're, hang on. Is that what we want next? I think that's checking and casting.
Now let's do something.
Nope. We're doing something a little bit different.
Suppose I have a class called puzzle. That has two overloaded methods. One is peek, which peeks at list 61 keys, and it prints out the last item in list 61. I also have a method called peek, which takes S list and prints out the first item. So my puzzle for you is as follows. Suppose I have a variable static type S list, SP, and I set it equal to a new S list, and so its dynamic type is also S. Then I create a variable of static type list 61b, and then give it a dynamic type S list. And they're pointing at the same object, and we call it elk r. So if I call the method peek sp, and I call the method peek lp, the question for you is which of these methods get called? In other words, what gets printed? So think about that for maybe 30 seconds.
All right, so first of all, will this compile?
Yeah.
Okay. Why will the second one compile?
So this is the instantiated as some.
Because the SL list is a list.
Because an SL list is a list, right? So I can do that. Okay. And what he's talking about in the first video is what do we call this?
The dynamic type. Or no, the static.
This is the static type. And can that ever change? Nope, that can never change. So this side is never going to change. Can this side change?
Yeah.
Yeah, it can, as long as it's inherited somehow. This is a this. Does that make sense? Right? So an S list is a list. So I can change this to any type of list. Okay, cool. So I've got these two peek methods. I've got peek SP and peek LP. Okay, here they are here. One's a get last and one's a get first, depending on what they are. So what's going to happen here? What's the peek SP going to do? Okay, so peek SP is going to get first. And if we look at this thing, right, it's elk are cool. That's how this did, right? Elk was added last, added last, added last. So if this thing is get first, what's the first line gonna print? Are we good with elk? Okay. That sounds, I'll take away the question mark. We sounded fairly certain on that one. Okay. What's the second one gonna print? So LP is what static type? List, and what dynamic type? It's an S list. So which one's it gonna call? So we're gonna go with elk again? The first method or the first get first? First method. So we're gonna get cool? Or are we gonna get elk? Ooh.
Because it's an SL list.
Doesn't, it's, I think we call it dynamic.
Oh, it's like the more specific one.
But that is it called dynamic method selection? Isn't the more specific than the?
Dynamic method selection, but we realize these methods are both, this is overloaded methods, right? So these methods are both in the same class. It's a little weird, but that's, you'll see why. Hopefully at some point this will make sense. All right, let's see the explanation here.
That's not likely.
No.
Right. Okay. So we just did all this work and we said, okay, well, you know, if there's like overriding, we just use the S list class. So obviously it's just gonna be, let's see, the S list. So it's gonna print out alpha twice. Okay. Nope, wrong. So why? Well, Josh, you should be complaining. I thought you just told me that there's a simple set of rules and you set me straight and I won't get confused. Well, I tricked you a little bit. This is overloading, and what we did before was overwriting. And I want to draw this distinction in a tricky way because I think this is where students get confused. Okay. So what happened here? Well, when it comes to overloading, we don't do dynamic method selection. Instead, when the compiler compiles the code, it says, okay, here's a peak method, right? There's one here that matches the signature. It just says, I know I have an slist, a variable of static type slist, so I'm going to call slist when I get to this point. The compiler also says, well, when I get to this point in the code, I'm going to compare the signatures. I'm going to say I have a method for lists and a static type variable list, so I'm going to do that when I get there. So in other words, the compiler, before it starts running, decides this is what it wants. It wants to call the slist oriented method up top and the list61b at the bottom. And by the time the code actually runs, we get elk and cool. So let's draw the distinction between overriding and overloading. Dynamic method selection only happens for overridden methods. And that happens whenever the instance method of the subtype overrides some method in the supertype. So for example, with slist, we have print. And that overrode a method in the list61b interface.
And we did that, right?
This is a great example.
To make our slist more efficient. Or not slist
So if I
print
ask
method.
the variable, like if I have a pointer to a variable, and I ask that class itself, hey, would you like to do something? It will say, great, I got it. I'm going to use the most specialized method I have available. This does not occur for overloaded methods. This is, for example, when a class has 2 methods or 3 methods or whatever, one for the supertype and one for the subtype. Okay. So here I have slist, list61b, set, and so forth. And so in this case, even though this is a subtype of this supertype, if I call peak with overloading, we use exactly what we say we want. Okay? That's just how Java was designed. I think it's actually a pretty sensible reason, but we won't pick it apart in this lecture. Now, there's obviously interactions between these on the discussion worksheet. Number 4, this will be available. There's also some Gorilla section work you can do to understand this better. But those are the basic rules. Dynamic method selection happens for overriding, not overloading, and that's pretty much as deep as it needs to be.
Okay,
One boring but important topic.
questions? Does that more or less make sense? Yeah, Dan.
So if we have 2 of the same methods in the same class and we call and it's like slist and list, the compiler is gonna choose the one that just matches the method signature.
The static type, yep.
Okay.
Yep. Because you couldn't have, right, you're not going to overload it unless you have 2 different signatures in there anyway.
They have to be in a different class, right?
But not if they're overloaded, right? Overloaded, same class, overridden, different classes. Yep. There we go with that. Okay, cool. We're done with that. Yay. All right. So how did we do? And I realized this morning that I did not give you a submit box for your vengeful S list. So I put that in there. So if you would go ahead and drop in your vengeful S list into Canvas, that would be great. Now we're going to do a little bit of discussion about encapsulation and why encapsulation actually gets broken with implementation inheritance. Yep.
Do we need to submit our remove class method as well? Or just this, if we use the remove class method?
Yep. So, well, it's if it runs in your vengeful S list, right?
Yeah.
Then it works in your remove list. Yep. Okay. Okay. Why don't you share it with us? Because you're probably not alone. So one thing I'm finding, thank you, Mary, because one thing I'm finding for some reason, especially in the AP classes, people are not speaking up when they're running into trouble. So only trick is, yeah, go ahead and share. Let me I wonder if it's because I'm sharing my screen. Try now and just see.
It was like, I think it's because I was trying to like debug it, and I think it's because of my like last pointer wasn't actually removing from the list, so I tried to create a pointer to the thing like right before the last thing, so it would like punch and all.
Okay.
And then it works in like vengeful list if I'm just removing like 2 things, but then if I'm removing 3 things, there'll be like a null that pops up.
Huh,
But when I had my regular removed lots,
uh-huh.
and then I printed lost items, it would only print the first thing I removed.
Could that have been a print issue, not a remove last issue?
Don't think so, because I was like going through and it seemed that it was like an issue with my pointers in removed lots.
Okay, so this is your
French.
vengeful. Okay, let's look at your S list remove last. Where?
So it's because when you're checking if it's not null, you should do temp.next. Because that's the, yes, that's the last item. Not the item itself, or not the second last item. And
Hang on, so temp, let's just. The temp 2 is confusing me here, okay. You're setting temp. Do me a favor, we comment out all your temp 2s just so we can make sure that we're getting this all right, okay. So I'll temp.next thing, okay, get rid of that, because you are gonna have to actually, with line 55, you want to make sure that's temp.next equals null, because you still need to set something equal to null, right?
Oh,
So we gotta keep that. Size minus, return last, return,
oh, and you're trying to return the last item, so you have to actually store the last item. And it's not temp item, it's temp.next item. To get the last item.
yeah, I feel like you should be able to do that without the next. Let me think about this one for a second. Oh, because I used a different method. Okay, got that. Sentinel. Oh, what did I do here? Oh, I see what I did. I did a totally different method. Okay. Turn P.
This works.
Try it and see, yeah. No last, that's not out there, okay. No, so cannot read next because temp.next is not, okay, yeah. So go back to your S list for a second. So you're not checking whether temp.next is null. So try temp.next, go back to temp.next for a second. And then temp.item, right? Because we are going to iterate through all the way to the end. And then if we do that, right, if we iterate through all the way through, then we want temp to be null, right?
I think that was my.
That's what you had, right? Okay, so let's just check that and see what's going on. That's not removing anything at all, right? Because it looks like what you're doing is you're removing 100 3 times, yeah?
Yeah.
Okay. So let's look at super.remove last.
Works fine, but rotating S list.
Okay, wait. So we have, you got two. You're calling super.remove last twice. So should be, we should have, S1 is your storage. Okay. Super.remove last, returning storage done. Okay. That looks right. Why are we still getting that? Okay, so go ahead. Yeah, go ahead and debug. Let's just see what's happening. So the debugger, again, so I'm going to teach you a couple different things right now. So one is, I'm screen sharing, it's fine. Okay, so we've got item null 9. Oh, because you created it with 9. Okay, just go ahead and add all the things. Go ahead and keep going, and then step into remove last. Wait, no, step into it. What do you see? No, wait, let's. Oh, okay, hang on.
You didn't override.
Yeah, wait, what's going on here?
You override vengeful SOs.
Why is it doing that? Let me. I'm also trying to do this online for people to be able to see. Okay, so why do we have, okay, start stepping through and let's just see. No, step into, where are we? Wait, oh, so you're, yeah, keep going. You guys keep going that. Okay, so we got thing.remove. Okay, so this goes back to here. Well, temp.next does not equal null, fine. Temp equals temp.next. Yep. Not equal null, okay. Yep. So it should take us to the end. Right? Ultimately, that should be there. Okay. T last equals temp.item, which should be 100. Yep. Now here is where temp is pointing at that. Ah. Oh, yeah. Okay. I see what you're saying. So go ahead and go next. Because what it's not doing, you're not getting rid of that thing. So every time you're not actually removing the thing you think you're trying to remove. I got it. So that's happening. Why is that happening? You can just go ahead and you can get out of there now. All right. So in your, we don't have an issue with anything in your vengeful S list. So it's in S list. So go ahead and scroll down. Let's go ahead and put in. Just keep scrolling down. Unfortunately, go all the way down. Unfortunately, the only way, okay, you do have that. Okay, so great. So go ahead and throw in a couple of remove lasts in there. Yeah. While Mary's doing this, and then go ahead and drop in a checkpoint somewhere in here. It doesn't really matter. That's fine. Yep. And then debug. And let's see if we can figure that out. Okay. Let's see. 8, 5, 3, 1 should get 2. Okay. Now step into that. Okay. Temp node equals sentinel. All right. So we should get a new pointer there, which isn't exactly pointing. Well, temp.next does not equal null. Yep. Temp equals temp.next. Oh, I see why you were doing the next.next, right?
Yeah.
Because you want to be at, yeah, okay. Mine is circular, so my code is totally different. So that's why, and I also used a helper method. That's a little bit different. Okay, so you get to there. And then you get to there. So you're pointing at the last item, so you don't actually have, yep. Okay, so let's try that. Let's go back to the code that we, so temp, yeah, you could just type it in anyway. So temp.next does not equal null. Temp equals temp.next. This is going to be a temp.next.item, right? Because what we're doing is we're hanging out at the next to last node, right?
Yeah.
And so we're getting all the information from the next to last node. We're going to return that item and then temp.next equals null. Return last. Yeah, Daniel, what do you see? Anything else that we're missing here?
No.
That looks like it should work. So let's go ahead and but this is what you had, right? So
I think we already tested this.
we did already test this, but let's see it in the visualizer just in S list because something's not working right.
Might be something wrong with the
Sorry, give me 1 second.
size or something. Oh.
Sorry, give me 1 second. I have to deal with this. Okay. All right. Temp.next. Okay, go through until we get to that node. Till we get out of our while loop. So there we go. Stop there. Okay. So we're at where we want to be. temp.next.item. So that should give us 2, so that looks right. Okay, temp.next equals null, so we should get rid of that last node. Go ahead. We did size minus minus, and we're returning last.
Maybe just try.
There must be something wrong with your size, then make sure you're
Remove last,
incrementing it.
size 1, 2, 3, 4. Size is right. All right, let's go through and see if it keeps working. So just go ahead and step over.
Should I, like,
Yep, go one more. 1 disappears. We're gonna remove last again. 3 should disappear. Wait. We removed 3 times. We have 2 things left. Get first and side. I mean, those, what do you get when, go ahead and step through that one. Let's just see if it's giving you the right thing. And then go to console. We should have printed 2. Oh, wait, and then go back to visualizer. Sorry, we should have printed 8. We did. I don't see anything wrong there.
Is get
Eventual, did you super, all super?
oh, that one.
No, it didn't. Oh, yeah, it did. There you go. Wow, that's weird. Yeah,
You already tested that earlier?
I thought we tested that, but okay. Apparently not. So I used, just so I'll just show you quickly what I did and why I was struggling with that a little bit, is because I used vengeful in my S list. I used a weird get last node private helper method, and so then all I had to do was enter remove last get last node. So I just got that node and then incremented through. But again, this is not ideal code because it makes this simpler in terms of not having to go to next.next, but I'm having to iterate through the list essentially twice.
that.
No, it's still O of n. So the funny thing is, and this is interesting to think about, is if you have, let's say, a for loop that goes up to n, and then another for loop that goes up to n, what's our runtime? Not nested.
Oh,
Not nested. So if this were nested in here, right, which it's not, I'm just going through the list and then going through it again.
And
It's O of n still, right? It's O of 2n, but O of 2n is O of n. So you can go through, you can use as many for lists to iterate through to some extent. You can use as many for lists as you want to, and you're going to stay at O of n. So when you're trying to solve some of these problems, sometimes it's a good idea to simply iterate through a list, do what you want to the first time through, iterate through it again, and do whatever else you want. As soon as you nest them, now you're into O of n squared. And that's where you run into trouble. Okay. That was weird. I don't know what was going on there. I will say, so, and I've been listening to a lot of stuff on AI. This is one good place, okay? Where if you run the debugger and you're like, I just can't figure out what's going on, and you start having to add a weird code. As soon as you start adding weird code and extra pointers and stuff like that, stop yourself for a second, take all your code, drop it into your AI of choice and say, hey, can you give me some hints on what's going wrong here? Okay, so that is, in this class, debugging your code, acceptable use of AI after you visualized it. Okay, so I want you to visualize it first, then you may use AI if you're really running into trouble. Because oftentimes, Gordon and I were looking at a piece the other day where it was an I and a 1 switched, right? Which I've done in my own code multiple times, where I think it's an I and it's a 1 and it screws up your code, and you look and look and look and you just don't see it because, well, it's just not obvious, right?
That's what's passing.
And the tests were passing, and so so that's a place where you can drop into AI, and AI would be like, well, hey, you got a 1 instead of an I. And so that is good use of AI. Okay, and it's something that, honestly, do we think that real programmers are doing that? Oh, 100%. AI programmers are using AI a lot. Okay, it doesn't mean that they write code. I mean, they do write code with AI, but they're still writing their own code. They're just using AI sort of assistance. Don't do that in this class because If you do that, you'll never get a job as a programmer. But once you get to be a programmer, you can figure that piece out on your own. But debugging is a useful case for AI. Yeah, dude.
It's kind of like, it's not that important, but in our, remove last, when we add something to storage, like lost items, is it, we could use like add first or add last, is there a better choice? Because should we print it like in the first thing that got removed or in like increasing order?
Great question. What do you think?
I don't know, I did add first,
Mhm.
because I thought it made more sense. Because my list is like 10, 20, 30, and then when I remove all of that, my print lost items moves. It prints 10, 20, 30, but I didn't know if it made sense to do it backwards, like add last, because I don't know, I didn't know which one was better, so I just tried to ask.
What do you all think?
You can decide.
You get to decide. You're the programmer. You get to decide. Now, what's the important piece of that decision?
That they both work, or,
Well, that yours works.
yeah,
But what's the important piece after that?
But you remember you did that?
that I'm consistent.
Okay. And why do we care about remembering or like, who is this all? Remember, who is this all for? Like in this context, who is this for?
Fine,
Client. So what do we want to make sure
they know what's happening,
they know what the result is?
okay.
So you're just gonna write in, and I would write in your comment, and ultimately you'd write in your API, right? Which is what you're giving to the client, right? The client never sees any of this. They're not gonna see your comments, they're not gonna see your code. You're gonna give the client, say, hey, you've got this fun vengeful S list, because that's what you wanted. Who the hell knows why, right? But you've got this fun, maybe it's some class, like okay. I'm trying to think of some analogy that makes like, okay, here's the list of kids that got kicked off the team or something like that, right? So we want to keep track of the kids that get kicked off the team. They're done in alphabetical order. They're done in order of the first kid that kicked off to the last. Like we just tell the client, this is what this does, and we make sure that they know that, right? And ultimately, who would tell you how they want it? The client. They come back and say, no, we want it done, the last kid to get kicked off the team first. So they're going to determine that. You're just going to make sure in your API you explain it well. That's all. Yep. Other questions? Okay, moving on. So we're going to do something a little bit sort of radically different. This is one interesting thing. And we've talked about it before. We inherit everything from the object class. I think we go into it here in terms of these are the methods in object. Okay, toString equals hash code, and then we have a bunch of sort of weird things: wait, notify, clone, get class. We're never going to touch any of these things. What should we do with our toString? You should always override your toString. Okay, equals. We should override our equals method, right? Because what is our equals method from object? Yeah, what we inherit from the equals method is equals, which is what? It's aliases. Are these things aliases of each other? Is that really what we want in most of our equals methods? No, we want to know if the list has the same objects in it, right? We don't want to know if they're the same list. We want to know if two lists have all the same things. We are going to ultimately override hash code, but that's next semester. Okay, but those are the three things that we care about in our object methods. Yes, all of these we inherit all of these from the object class, and we'll see what we inherit. Just like what's our toString? What do we inherit as a toString? If I create an object and don't put it in a toString and I print it, what do I get? Object name, hexadecimal code of memory. That's useless, right? Hash code does a similar thing that gives us a semi-useless hash code, okay? Or not always useful hash code. So these three things are not useful in the way that we're given them from object. And that's why we tend to override them. Okay. And this is just the whole thing about, right? If we create something, if we extend, or we inherit, then whatever we inherit from in vengeful S list is an S list, right? Set extends S list would be a bad idea, right? Can you all think of any sort of analogies from the wider world that work or don't work? Something is a something else.
Anything?
Yeah.
Dog is an animal.
Dog is an animal. Great.
SCR.
Okay. Think of a bad example then. What's a non-example?
The dog and the cat.
Okay, that's a really, really clear one. What's a sort of a messy one?
Tomatoes are fruit.
Tomatoes are fruit. Okay. Think little less literally. I think he gives a good example in here. Oh, no, he doesn't. What about if I had claws as a subclass of cat?
They claws or paws?
Claws.
They have claws.
Cats have claws? You declaw them, but okay. Tails and cats. Most cats. Would tails be a good subclass?
There's one cat.
In most cases, but some cats may not have a tail.
So it's the trick is, but what's so you all are focusing on something a little bit different and not quite right. A cat is an animal. A cat has a tail. Don't use has a relationships. Okay,
Instance variable
what's that?
with the tail.
It would be like an instance variable or something else, but that's the one that people tend to run more into trouble with, right? It's pretty clear that a cat is not a dog, and the tomato is the fruit thing, I don't know about. I'm not going to get into that one. But and Java's actually did this, which is really kind of unfortunate. We're going to talk about stacks a fair amount. We're not going to spend a lot of time on this example. But a stack, you simply push and pop, right? Because what do we care about with a stack? If I have a stack of plates, what do I care about interacting with a stack of plates? Just the top. Do I try and grab the bottom plate? A middle plate? No, you don't, right? You just push and pop is just, I'm just pushing and pop. In other words, push, I put something on the top of the stack. Pop, I take something off the top of the stack, okay? However, in Java, okay, they wrote stack and they made stack a vector, okay? So who knows why they did this? So stacks have all list operations. Okay, does that make any sense? No, because really all you need to do is have push, pop, and size for stack. But if you go in, stack's got all of these things.
But by vector, you only have a direction and a.
No, vector is a slightly different thing. Just it's a list. Just think of it as a list,
Okay.
right? But we don't care about 70% of this stuff in a stack. So that's bad inheritance. Okay, what is encapsulation?
Like hiding some back-end things from the client,
Some backend things,
everything.
everything. You want to hide as much as you possibly can from your client. Okay. So encapsulation is you wrap everything up in a little container and you say, here's the things you can do with this thing. Don't worry about how it works on the inside, right? If I give you a car, right, you're now, I don't care, whatever driver you want to be, right? Do you need to know how to change the oil, replace your brake pads? In the olden days, it used to be easier. Nowadays, right, change your fuses. Do you have to know all those things to be a race car driver even?
Really save money, but you don't.
No. If you like, so when you go to get your driving test, Alex, do you need to know those things?
No.
No, that's encapsulation, right? Encapsulation is you don't need to know any of those things. Your mechanic might, right? They're the software engineer. And these days, more and more mechanics are software engineers because your car is almost entirely electronic. Okay, but that's encapsulation. So, right, we create layers of abstraction. That's why we create all sorts of, different classes and different methods so we can sort of hide the information as much as possible. Part of the reason we do that is because, and the way that Hug approaches this class is that our entire job in building software is managing complexity. Okay, so all these things we're doing is really complex, but what does the end client get with, say, S-list? Simple thing. They can add to the front or the back, and they get a list, right? That's what a client gets. Okay, so it's super easy to them. I create a list, I can add to the front and the back. Boom, we're done. Obviously, under the hood, there's all sorts of things going on that you need to think about. And when I add more than 8 things, it resizes, and I got to get that right. And that's all the complexity that we're managing. And we abstract that away from anyone using the end product. Okay. Implementation is completely hidden. So this is our array deck. That's all that a client sees. This is what they can do. Okay. So what are they actually looking at when they look at these things? Sort of more or less. Where do we find all these things?
Documentation.
Which documentation?
API.
It would be the API, but just like what we have right now in your array deck, where would I find all these things? In the interface. The interface just gives me these method names, right? So I can use my interface sort of as my, for right now, as my sort of documentation for my API. Okay. Some of you ran into this, like we ran into this when we were talking about it, and these were questions he was getting when people were in his class were building array deck. How do I check, right? When I'm doing tests, how do I check the, length and the resizing methods, right? Well, do I have access to like all the different things that I want to have access to? No, so you still need to figure out how to test them, right? Without actually going in and digging into the underlying code, even when you're testing your own code. Okay. Okay, so he's heavy into Plato's allegory of the cave. But there's a problem here when we get to it. There's a problem here. Okay, that's a potential problem that we'll see. Okay, we have a dog class. Right? Dog's got bark. We've got bark and we've got bark many. Bark just prints bark. Bark many iterates through to the number of times and it barks. All good, right? Okay. Functionality is just the same with this class. So now look at this class. Now someone at the dog manufacturing software decided to change the implementation, okay? Because as a client, I don't get into dog. I just have bark and bark many, right? Okay, I just switched these two. Are they still going to work? Well, if I call bark, I'm calling bark many once. So I come down here and I iterate through, and how many times am I going to bark? I'm going to bark once. So does bark from the outside still work?
Yeah.
Does bark many still work? Because what bark many is going to do is it's going to go bark many. It's going to say bark many 3 times. And I iterate through and I print bark 3 times. No, but it's just proving a point. No one would actually, hopefully, no one would actually do this, but it happens with more complex code.
That just looks.
Of course it looks weird. That's sort of the point. And we're going to see why it is weird in a second. But do we understand that we can't see this from an outside perspective? If we've made those changes, theoretically, it looks the same in terms of my methods I can call. Right? This hasn't changed, and it seems to work. However, okay. What did I just skip too many pages? No, there we go. Okay, we've got verbose dog, many bark 3. As a dog, I say bark, 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 or something else. VD is a verbose dog. Okay, so here we've got an overridden bark many method. Okay, and this is a verbose dog. So he says, as a dog, I say, iterates through and calls bark. Right? Now, dog's got a bark and a bark many method. Verbose dog only has a bark many method. What's this going to output? This is where all that static, dynamic type, overridden versus overloaded stuff we just talked about comes into play.
It's gonna call dogs.
That's why we just went over the overridden versus overloaded. This is a verbose dog and we call bark many. Where do we think we go? Two verbose dog. We call bark many. That's bark many 3. I'm going to print out as a dog, I say, iterate through and call bark. Yeah?
Yes.
Where does bark go?
Oh,
Verbose dog doesn't have a bark method.
it goes to the dog.
It goes to dog class and prints bark.
Yes.
Yes, Logan?
Yeah.
Right? Because I don't have a bark method in verbose dog. Because it's a verbose dog. He only barks a lot. Little yappy dog.
Hey,
So what are we voting for? A, B, or C? A. We all good with A? Okay. In fact, it does. As a dog, I say bark, 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 right? Because again, bark many, we call the overridden method. Inside of here, we go to this bark method. Okay, now we flip. We go to the second set of code. Now bark calls bark many, right? And bark many prints the bark thing. This is the switched that we would never do. Now we've overridden bark many, and we've done this and called bark. What's going to happen here? Is a dog I say bark, 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 or something else?
is it gonna break?
It's gonna be B.
We got B, we've got broken. I love the consternation looks.
Oh.
Okay, we're gonna do proper voting this time. I need little clickers. A, B, C. Who's voting for A? You got a vote. We got one vote for A.
Well, it's actually.
I want to keep track of names. I just want numbers of votes. B. No B's? C. 1, 2, 3, 4 C's. My favorite ice cream place would be in 4 C's. Okay, sorry. Obviously different C. Actually not necessarily different, but it's never mind. Okay. What's the something else?
It's when it calls bark many, and then it calls.
Okay, so let's talk it through. We call verbose dog bark many. We come to this bark many, right? We're all good with that. Okay. Here it calls bark.
Then it goes to the dog's bark.
It goes to the dog's bark and calls bark many. Which bark many?
The dog class one.
The dog.
This one? Well, if that happened, then what would happen? What would we get?
Bark, hey,
Bark, bark, bark. Is what we get.
Wouldn't you get A though?
It'll be as a dog.
It does print as a dog, I say. Right, so we get A.
Oh, no, but it's on another line. Like the bark.
like it would be like that.
Oh, it'd be as a dog, I say. Oh, well,
And then.
that, presume that's not there. That actually, that was a good catch, right? This should be, if it's gonna print that has to be print, not print line. Okay, good catch. Yeah.
So when we're in bark many and verbose dog, we call bark in the dog class, and then in the dog class, in the bark method, we call bark many, it uses the dog's bark many method.
No.
It goes back to,
So what happens?
so it breaks, right?
It does break.
That's what I was thinking, because
It's an infinite loop.
because it never goes to its own bark many method.
Correct. So this bark many, right? Because what's the dynamic type, right? This is an overridden method.
It's a verbose dog.
So it goes to verbose dog. So it comes back to bark many and calls 1. And then it calls bark, and then it goes back to bark many. And it's an infinite loop.
What would that print on a console? Would it just,
Did you see my one when I had my infinite loop the other day? It would probably be a page full of barks.
okay.
Yeah.
Is there like an error message?
Would it? No, actually, it would be a page full of, because there's no print of bark. What would be a page full of? As a dog, I say, because that's the only thing that's actually ever printed in either of these methods. It never goes to printed bark.
Is there like a exception error for when you get an infinite loop in Java? Or is it just gonna give you infinite as a dog?
Infinite numbers is a dog, I say.
So if you let it run for like a day or two, will your computer like,
It'll crash. Yeah. Or it'll overheat. I told you what happened with one of my intro classes, didn't I? Someone got into an infinite loop. I hope it was none of you, but it's okay if just don't admit it if it was. Someone got into an infinite loop, and instead of like, because you can shut down an infinite loop in virtually any program, just close the tab or whatever, close their computer, and didn't realize that the infinite loop was just going to keep going with their computer closed, and it just shut. I mean, it just went until it shut down their computer, but so it didn't really break anything. But don't do that. Because an infinite loop is literally an infinite loop. Most like IntelliJ, I think will shut it down after a certain amount of time. But you don't want to do it in a lot of IDEs because it will.
Should there be like a Java, like built into Java error for infinite? Or do they want you to like?
Well, no, because it's not a compile time error. Right? So do you want to see an infinite loop? Didn't I show you one?
You had one for the other.
The null, right? Yeah. Okay. Yeah, that's what it'll do. Okay. So there we go. It gets caught in an infinite loop. Finally, last quick thing here, and then we're gonna. Oh God, what time is it? Are we done?
40.
Okay, I'm gonna leave a couple minutes early just because I gotta haul my butt up to my advisor meeting. How did we get through the entire class? Okay. Yeah, we do. All right. So type tracking and casting. Does that line, for each line of code, determine does that line cause a compilation error? Okay, so we're gonna go through each line. Vengeful S list VS1 equals new vengeful S list integer 9. Error? Okay. S list integer S1 equals VSL. Error?
No.
Can I have a static type that's an S list and a dynamic type that's a vengeful S list?
Yeah.
I can, because a vengeful S list is an S list. That's all fine. S1 dot add last 50. S1 is an S list. Add last would be coming, the implementation would be coming from what? Why S list?
Just does.
Well, think about your code. Why does add last come from S list?
Because we call soup.
Did we override add last? What's that?
We overrided our last eventual lesson.
We did? Add last?
No, remove line.
Yeah, so this doesn't have a problem because we didn't override that. That's coming from S list. No problem. S1 dot remove last. Did we override that one?
Yes.
Yeah.
We did override that. Any problem there?
No.
What's that?
So that would be from the vengeful.
Yeah, so when we call that, where is it going to come from?
Vengeful S list.
Vengeful S list, because that's my dynamic type and it's overridden. Right?
Yeah.
Awesome. S1 dot print lost items. No, S1 is what type of thing?
And S list.
It's a static type S list. It's a dynamic type vengeful S list, and I'm calling print lost items, which comes from vengeful S list. Does it exist in S list? What happens? Error. We get an error here. Well, the compile time, what happens is a compile time, where does it look? So we've got this is S1. Okay. And when it hits this method, where do I look for the method at compile time? Let's say add last. Where do I look for the method first? Compile time, it actually looks in S list first. It exists in S list, so it compiles, but then when it dynamic runs, where does it grab the method from? Vengeful. It grabs it from here. It uses this one, but it looks for it here first. So when I call print lost items, it looks for it here and says, hey, no, there is no S list remove lost items method, and it throws an error. Okay. So we get a runtime. What do we got going on here? Just explaining it, I think. Yeah, we get a compilation error with our print lost items because it doesn't exist. Okay. Okay, type checking. So this is why what we can do, obviously we can't switch those two things. All right, slightly different. I can be quick. We have compile time types as well. Okay, we got a public static dog, max dog, D1, D2. Okay, call to max dog will have compile time type dog. We good with that? Right? Because I'm returning a dog. And we're going to see this pretty often, right? We've already started to write methods that return interface types, like a list. I'm going to return a list. And why are we doing that? Why are we creating methods that return a list as opposed to an array list or an S list or a list? Yeah, so I only have to write max list once. I don't have to write max dog for poodles and chihuahuas and mutts or whatever, right? So I have poodle Frank equals new poodle Frank and poodle Frank Jr. equals new poodle Frank Jr. I call larger dog, max dog, Frank and Frank Jr. Any problem there? No, because they're both poodles. I call max dog, okay. And I get, what type of thing do I return? A dog, and I'm assigning it to a dog. Here I'm saying, hey, poodle, larger poodle, max dog, Frank and Frank Jr. That doesn't work. Why? Because what is max dog type? Dog, and I'm trying to say dog is a poodle. That doesn't work. Does this start to sort of make sense? Poodle's a dog, but a dog is not a poodle. Right? So this can be a poodle, and it is, but it's going to return a dog, and I can say dog, larger dog. How can I fix this? I could change this to dog. Could I change it anyway on the right-hand side of the assignment statement and make it work? What do you mean poodle? Can I? They're both poodles. So can I compare two poodles? Okay.
Can you cast it as a poodle?
Boom, I can cast it as a poodle. Okay. So I can say, hey, poodle, I have max dog, this returns a dog. Can I cast the dog as a poodle? Can, right? And I can call it a poodle. Now we have to be super careful here because what am I doing to my compiler? I'm changing the, yeah, and I'm saying, hey, this thing's a poodle. I'm guaranteeing that this thing's a poodle.
If it's not.
But if it's not, I have problems. Okay? If I'm comparing a poodle and a Malamute, and the Malamute's bigger, right? I've still got a dog, and this method will work, but I've got a Malamute, and I'm saying a Malamute's a poodle, and I'm signing it to poodle class. That's not going to work. Okay? So that's where you can run into, oops, I didn't even realize I was using the same example. So I got poodle Frank, Malamute Frank, Malamute Frank Senior. We've got these two things. I cast it as a poodle, and we're going to class cast exception error.
Because the Malamute isn't a poodle.
Because the Malamute's not a poodle. So because the Malamute's bigger, right? Malamutes happen to be bigger than poodles, typically. So he's going to be Frank Senior is going to be the larger. I cast it as a poodle. This would all work if they were both poodles. Or the other thing that's a little tricky is that if for some reason Frank were bigger at the start, this would work. And then as soon as Frank Senior got bigger than Frank, then I'd have a problem. So that's an error you can make where you're not going to see it at first because it won't catch it until in the comparison, the Malamute's bigger.
That would be one big poodle.
That would have to be, well, I've seen some like a standard, you ever seen a standard poodle? Like
I thought Malamutes were like those massive.
a baby Malamute,
That's
little mill, puppy Malamute. Okay, we're going to have to hold off on higher order functions until next class. Questions on any of that stuff? Is this starting to sort of, I know I sort of been throwing a lot of concepts at you and they may not all fill, but do they starting to sort of coalesce a little bit? Okay. Yep.
Oh, no. I was gonna ask if you can cast the left side as poodle, but that doesn't make sense.
Yeah, you wouldn't cast this side. So I mean, again, if this were dog, then would I even need to cast this side?
Oh.
No, that's not a problem. But if I'm trying to, for whatever reason, get a specific type of dog over here, And quite honestly, you know, dogs, it may not make much sense, but it is gonna make sense. As we start to do things, we're about to see it actually, next class, hopefully, in terms of doing comparisons of things. So if we want to be able to compare things, we need to make sure they're the same types of things. Okay. Cool. Have an awesome rest of the day. I think I'm probably. I'm going to give you a leak code. I'm trying to decide if I'm going to give you maybe a little bit of reading. We do have a textbook that goes along with this, which is going to be useful as we move along. I'm not sure it's useful just yet. Or do you guys want to read the article I sent you about computer science? Yeah. Okay. Cool. Have a great rest of your day. And then I need to do. All right. I've got to erase my incredibly poor spelling on the word. Oh, no, it's okay. Yeah, I'm like, what are you giving me? Have a great rest of the day. See you later.